Our final keynote for the day, I'd like to bring up Robert Hodges. Robert Hodges is the former CEO of Continuant, which was acquired by VMware in late 2014. He works on cloud data management services for VMware's cloud offering, vCloud Air. Robert has over 3 decades in the field of databases and has worked with technologies ranging from pre-relational systems to Hadoop to NoSQL. He has a wide range of technical interests and is currently focused on DBMS operation and hybrid clouds. Please welcome Robert Hodges.
Thank you. Great. All right, thank you. It's great to be here. Before I get started, I'd like to echo everybody else and thank Percona for organizing this conference and setting up these talks. It's a tremendous honor to clean up after 3 really good keynote presentations. What I'd like to do in my talk is shift gears a little bit and talk about the cloud, and specifically some things that we're doing at VMware to help manage data in cloud environments. So when Continuant was acquired by VMware, we were brought in with a specific mission, and it was to help build innovative data services in a new kind of public cloud. And I'd like to give you just a little bit of context about why we felt it was necessary to have a new cloud. If you look at the existing public cloud models, they're basically disconnected from the environments where people traditionally run applications. Look at Amazon, for example. It has different management. It has different virtualization technology. It has different services for things like storage. Moreover, at least at the beginning, it had relatively limited integration through the network with the environments where people were doing other types of IT processing. And so our goal at VMware is actually to build a cloud that is compatible and integrates with the on-premises data centers. And as we go through, you'll see why that's an important problem to solve. So as I go through this talk, I'm going to hit on 4 points. I'm going to talk about building a cloud that leverages very powerful virtualization technology. I'm going to talk about seamless migration, so the ability to move things easily back and forth between these environments. I'm going to talk about the issue of attacking enterprise problems and trying to solve them completely, thinking not in terms of technology components, but as problems that need to be solved and solved end to end. And then finally, a little bit about secure and efficient data integration. I'd like to hop into the first of these points, which regards virtualization and the technology stack. So I think there's kind of a tendency, particularly if you're not directly involved in virtualization, to think of it as something of a solved problem. You know, you've got to virtualize something, just go grab Xen, grab KVM, and use those, and then you're off to solving your real problem on top. That's not quite the case, and I'd like to demonstrate that by showing a very interesting feature that VMware has in the latest release of vSphere. vSphere is the virtualization product that we sell. Runs in a huge number of enterprises worldwide. In fact, how many people are VMware customers here? So I can't see. It's a fair number. Thank you. Glad to have you here. So let's look at a very, very familiar problem. This is database high availability. So the basic issue here is your database fails, your applications are now down, you need to get it back up and running somewhere else so that you can continue processing. So traditionally, particularly in enterprise environments, there have been a couple of solutions to this. One is to use a shared storage array. So processor host fails, we're going to stand up another processor host somewhere else that's going to attach to the host is going to attach to the storage, restart the database, and continue. That has some issues, obviously. I mean, if your SAN fails, you're sort of screwed. So it's sometimes good to have, in fact, in the MySQL community, we use shared nothing approaches to this. So use shared nothing storage replication, for example. So in that case, we're replicating the blocks as they're written. When there's a failure, we're going to go ahead and mount the secondary file system stand up a new MySQL instance, restart, and off we go. Now, these have some very well-known problems. So, for example, if you have active connections in both of these cases, they're going to be broken and the applications will need to reconnect. Another more serious problem, if you're doing heavy-duty data processing, is you lose your caches. So your buffer cache, and unless you're managing it very carefully or using advanced features, you're just going to lose your memory contents, and they'll have to be reloaded from storage. Traditionally, I mean, this has improved over the years, but traditionally this could result in databases performing at lower levels, sometimes for considerable periods of time. Another issue is data loss, particularly when you have shared nothing replication. And as a result, what people have done, in fact, we've all done this, I've worked on this for years, is build clustering frameworks on top that alleviate some of these problems, but at the cost of introducing more complexity into the operational environment. So VMware has a very interesting take on this. This feature that I'd like to introduce to you is called fault tolerance. And what it basically does is it mirrors VMs. And I'd like to walk you through the parts very briefly. So at the bottom you have disk or storage replication. We call these VMDK files. That's the representation of storage in a VM. So that's replicated across, familiar technology. At the top, we have automated failover. We use a voting disk model so that even if your management tier is down, the virtualization layer, in this case, the hypervisor ESXi, can decide, hey, we've got a failure. It's time to promote our secondary. The really interesting part is in the middle, because what we do with this feature is we mirror processor and memory state. This is kind of mind-boggling when you start to think about it. What do we mean by this? Well, we mean the state of registers. We mean the state of caches. We mean the state of things like network controller cards, storage controllers, things like that, plus all the memory. And then taking into consideration the fact that this actually supports multi-processor SMP models. It'll work with up to 4 virtual cores. So taking into consideration the fact that there are things like memory barriers that would make it very difficult to apply this data or to replicate this effectively over to a shadow VM. It's sufficiently mind-boggling. I had difficulty believing it would actually work, but it does. And what we do is we have a very, very fast checkpointing mechanism that incrementally checkpoints, pushes this stuff over, and also maintains full consistency with the underlying storage, which is also controlled by vSphere. This is a very interesting piece of technology. And if you haven't heard of it or used it, it does give you a kind of interesting new option for HA on MySQL. So what you can basically do is set up your MySQL instances. You enable FT just by doing a couple clicks through the vCenter API. You have to use the most recent version of vSphere, which just released. And you have your primary, you have your secondary, you have your data stores set up. And if you actually get a failover, for example, the VM crashes or something bad happens, it will basically just shift it over automatically. And the interesting thing about this is it's completely transparent to applications. So this is a very innovative piece of technology. I mean, one thing you might be thinking is maybe it's time to run out and write a big check to VMware. I will tell you it has some limitations. Only 4 vCPUs. It doesn't work on all workloads. If you imagine something that makes a tremendous... Did I lose my audio? Oh, okay, good. Sorry. So if you make a lot of modifications to memory, this would not work. You've got a 10 gigabit Ethernet connection. You can actually saturate it if you do enough operations on memory. It happens that databases actually don't trash the memory that much because they tend to be I/O bound. So that's not a problem. I think the deeper question beyond, sort of should you try this is kind of a reversal of the way we've been accustomed to think about HA, particularly in the open source community. We think of HA as being as something that we have to handle at the application level because everybody knows that hardware is fallible, and we're working on unreliable hardware. What we're doing here is we're taking away that fallibility because the virtualization layer makes it disappear. That's a very intriguing notion and brings up some kind of interesting issues when you think about designing clouds, when you think about compatibility of applications. So FT is just one of a bunch of great features in the latest release of vSphere. I think another one which is very interesting that I haven't tried yet, but it sounds great, we call it VM forking. I think it has an official name that the marketing department cooked up. But the basic idea is you have a running VM, you can actually fork off another one dynamically, which has the exact same state and then can run independently. This has a really interesting application potentially for maintenance. You're doing some maintenance operation, you fork a VM just so you have a copy of where you're at. You do your maintenance. If it's fine, you throw the fork away. If it fails, you can go back to the fork. So it's another interesting kind of idea that goes back to the snapshot model for doing online maintenance. So this, I hope, gives you sort of a sense of some of the power of the stack that we have to play with at VMware. And what I'd like to do now is kind of turn to how we're making this into a cloud. And here I'd like to hit on a couple more points. And I think that the issue here is we take the cloud to the next level for data management, but also in general, is that you want to solve hard enterprise problems in a compatible way. Let me explain what I mean by that. So here's how vCloud Air works. We've got sort of a very high-level architectural diagram. You've got the physical hardware substrate. That's your storage, your physical networking, your boxes, sort of Xeon, whatever infrastructure you're using. On top of that, you have your virtualization stack. So the basic virtualization, vSphere and the ESXi hypervisor. On top of that, we put a layer of networking and security so that we can build virtual networks and basically allocate what we call virtual data centers on top of it that are virtualized. And then there's something called vCloud Director, which is the multi-tenant management layer that makes all of this stuff work. So it carves up the vSphere underneath, we call them cells, makes all this stuff work, spins up instances, does all those sort of housekeeping tasks. And then finally on top, you have a nice portal, and then you have your true cloud services. So getting to the compatibility issue, right in this architecture, that problem is not completely solved, but we've gone a long way to solving that problem because the vSphere technology that we're using underneath is actually the identical technology that's running in a huge number of data centers all over the world. So if you need to move an application that's running on vSphere now, for example, you can just turn it into an OVA format and you can just push it, sort of upload it and then start it in vCloud Air. It's as simple as that. And we actually do this to set up demos. It's very, very simple to use. So that compatibility problem we go a long way towards solving that. We're also, if you begin to think about some of the other features like resource management, the FT feature that I talked about, basically you can move applications into this cloud without having to rewrite them. And that's a really fundamental property. This is a migration, not a rewrite. As we move to data, so we're building data services. That was, as I said, why we were brought in. So the first data service is Database as a Service, DBaaS, from Microsoft SQL Server. So you're thinking, wait a second, am I in the wrong room or something like that? Well, there's a simple reason why we did it. It was already underway when we came in. And the fact is, there's an awful lot of Microsoft SQL Server out there. In fact, how many people use Microsoft SQL Server? Just curious in the audience. It's quite a bit. I think I always thought, I used to work for Sybase, so I have a kind of soft spot for it. I always feel like if they'd written it on Linux, if my Windows had made it run on Linux, they would have given everybody a real run for their money. So that database as a service is something we're working on right now, and it does the usual database as a service type things. It has a nice portal, has an API to spin things up, do backups, control it, get status. And then it has a pool of instances which are then mapped into the networks of the applications that are running inside vCloud Air. So this is kind of a very, very basic service that I think most people recognize is necessary in any viable public cloud. Of course, MySQL Server is not the only database out there. There's a number here that, of course, my favorite one is sitting there in the middle. So we'll get to those as well. I think you can, we just have to start someplace, and Microsoft SQL Server was the place to start. So MySQL is coming. What's kind of interesting, actually, is you're in enterprise environments is that sometimes, we've talked about open source here quite a bit this morning. You sometimes have to make the case for why MySQL is important. And that's something that we bring to the table because we're sort of in the MySQL community and able to explain to people why it is that MySQL is so great. It's very simple to spin up. It has minimal licensing dependencies. And in fact, some of the features that are being discussed here today, like encryption, make it even easier to make that case. So I think you'll see activity on MySQL in the not too distant future. Getting back, though, to the enterprise problems, if you look at what really keeps CIOs in enterprises large and small up at night, their biggest single HA risk is site failure. So if you think about this table that I'm showing, which is showing reliability up to, or availability up to 5 nines, just think about what it is that takes you down a notch. Well, obviously, the biggest problem is to have a site failure that puts you out for a few days, where you may, in fact, lose data, so on and so forth. So this is a very, very complex and gnarly problem. It is not easy to solve. It turns out that VMware actually does have a fairly good solution for this that works in enterprise data centers. It's called SRM, Site Recovery Manager. So one of the interesting challenges is to take that knowledge about orchestration and sort of the solution of the site recovery problem and apply it to the cloud, because there's a tremendous benefit to being able to actually make the cloud turn into an alternate site that is sort of minimally present as long as you don't need it, but where everything spins up and you start to run, use resources when you actually need to do failover. And in fact, we have a product already out called vCloud Air DR, which is, I think it's in its second release. And basically what this does is it uses what we call VMDK replication. I mentioned it a few minutes ago. It's replicating the state of the VMs over into the cloud. And then if you need to do a failover, you can just go over and start them up. You actually, right now you have to start them up individually, but you can basically bring this up and you have applications that are up and ready to go. Now, this is only a partial solution right now for a number of reasons. And the first and biggest reason for data management is that it has what's called a recovery point objective. That is the window of time that you can actually lose data of 15 minutes. So that's basically saying that if you make a commit on your on-prem system, it could be up to 15 minutes before the bits for that commit reach your DR site. I think for most database people who are serious about managing data, we think of that as unacceptable. I did some work on replication a number of years ago for one of our customers, and I had to put some features in to enable better fsync support in the replicator pipelines. And this, because basically it was to solve a problem of having stuff committed to disk or storage on the master before we actually let it go to the slaves, so we didn't get weirdnesses where slaves would come up ahead of the master. It increased the latency by 1/3 of a second. I agonized about that for months. And I think if you look at the kind of sort of tolerances that we have in MySQL replication, we think of a second or two to move data between hosts is a very long time. We need to solve that problem. And in fact, one of the things that we're actively working on is to extend the basic VMDK replication model, which is great for applications because they tend to be more or less stateless. They may maintain configuration files. They have sort of minimal state and where consistency is not a big deal, to actually extend this using live database replication. And as we all know, database replication is tremendously efficient. It's fast. The bin log, for example, in MySQL knows exactly what has changed. and can replicate it, sort of generate a representation of it in the in a minimal form that then can then be quickly replicated and applied to other locations. So that's a big next step in this whole DR story. I anticipate that this is going to be something we'll be working on for a period of a couple of years. I probably shouldn't mention that, but it's a very, very complex problem. But this is one that we're very focused on solving because it's so important to so many people. So I'd like to turn to a final point, which is hybrid operation. And hybrid operation is something that's just a necessity for enterprises. You may be moving to the cloud, but you still have on-premises data centers. There are very few businesses that exist now that can move fully into the cloud. And there's a number of reasons why they might not do that. We'll have a look at that in just a second. So this is a problem that we need to solve to be able to integrate these environments. And the fundamental reason is just if you put some numbers on it, not everything runs in the cloud. In 2009, there's some interesting research at VMware that showed in 2009 about 2% of all VMs, known or believed VMs, were actually operating in a public cloud. It increased very rapidly by 2014, and at that time we believe it's 6%. This is still a tremendously small number. So, and if you think about why it is that things don't move, there's just a bunch of reasons. One simple reason is that people have existing systems, they work great. A data warehouse, for example, you're not going to move it. Moreover, there are many applications that by definition almost can only run in a single location. That's a data warehouse. You put it in one location, and everybody else, no matter where they are, they have to move their data to the data warehouse and load it in there. So one of the things that we are therefore very, very focused on this cloud is almost before we start to build singing and dancing data services is to get the networking right. So in vCloud Air today, there are 3 options to move data back and forth, and all of these are designed to integrate networks in a secure and performant way. To me, the most interesting one is we do have the capability of doing a stretched layer 2 network, so you can actually have what appears to be a network operating, sort of a, same subnet operating across between on-prem and vCloud Air, but we also have VPN, IPsec VPNs. Those are fairly commonly used. And then for a lot of enterprises, they just use dedicated connections. So you can call your telco provider and actually have a connection put all the way through so that you control the wire and have secure, high-performance communications. And so that's been a pretty big deal and kind of an obvious component that's necessary to enable this integration. There's another thing that's a little less obvious, which is that in addition to extending the networking between the environments, you have to extend the management across environments. And that's actually where the Continuant product set comes in, because we know that we're building services in the cloud and we're actually embedding the Continuant technology in that, but we need to continue to have that technology working in the on-prem environments as well to enable things like clustering, replication, and so forth, which are all part of this data integration story. So for example, we're still continuing to work actually quite hard on what we now call VMware Continuant, which is the Continuant clustering product. And what this does, if you're not familiar with it, is it enables a form of database virtualization. It takes off-the-shelf MySQL, any of the current MySQL builds that are production ready, puts them together as replicas, supplies replication between them, supplies management, so it has automated failover, and database-aware connectivity so that it actually looks like a single database to your applications. So this is a very powerful product. It's in broad use among our customer base. And in fact, you might ask, well, given features like FT, this sort of singing and dancing availability solution that works for up to 4 vCPUs. Why would we continue to do this? Well, there are other availability problems that still need to be solved, and a very, very important one is online maintenance. If you look at the effect on downtime, in fact, maintenance is usually the biggest component of downtime across the board. So what VMware Continuant does is it allows you to do rolling maintenance in a relatively simple and easy to manage way. So, upgrade a replica. If you don't like what happens, throw it away. Continue until you're done. So this is a very important technique which we provide the plumbing for, as people are managing their data. Another thing that we do is that's quite important is we load transactions to data warehouses. So we have very good data extraction capabilities from MySQL. We've basically kept pace with the binlog improvements. And in fact, one of the latest things we put in is to enable those continuant clusters, which I just described, to have transactions replicate out and into the most commonly used data warehouse technologies. So we have customers deployed on Vertica, Redshift, Oracle, as well as Hadoop. And one interesting feature, just to give you an idea of why this technology is something you should consider, is the replicators know that there are multiple nodes in the cluster, and they can automatically switch between nodes if one of them goes offline. So this is once you have this set up, it basically just works. And because it's reading off the binlog, it can push the data into your data warehouse in something close to real time. In fact, basically as close as you would like. So with that, I'd actually like to announce that Continuant Tungsten 4.0 is, that should be VMware Continuant 4.0 is on the way. Sorry about that. The marketing department, don't tell the marketing department, they'll kill me. So we're doing our next release. This has been under wraps for a while. When you go through an integration into a larger company, you have to adjust to a lot of things, build systems, new set of lawyers, all kinds of stuff like that. But the main features that we're continuing to push forward with this are to continue to offer true high availability from MySQL, including zero downtime maintenance, plus a bunch of other great features, for example, load scaling on replicas. Of course, MySQL disaster recovery, so solutions that work over distance between environments, any environment you care to run in. Advanced replication for MySQL as well as Oracle. And then finally, that real-time data warehouse loading that I just talked about a minute ago. So we're continuing to actively develop this, and we're continuing to be actively engaged in the MySQL community as we do so. And what I'd like to encourage you to do is, speaking of communities and open source, keep an eye on this space. In addition to announcements about 4.0, you can expect other news from us over the course of the next few months. So we have some interesting things on tap, and I'm looking forward to being able to talk about them in more detail. So coming back and just kind of wrapping it up, if you ask that question, again, what has the cloud done for my data lately? So we are building the next generation of public cloud, and it has these important properties that I described. Sort of this leveraging, this very, very powerful virtualization stack, enabling as close as we can get to seamless migration of applications and data out of on-prem environments into the cloud and vice versa. Providing complete solutions to enterprise problems, and then finally handling the problem of secure and efficient data integration. And not just networks, but also the application software, if you will, and the services that are necessary to move the data, for example, out of a binlog into a data warehouse across these environments. So that's basically what we're doing. I'd just like to invite you to attend some of our other talks. My colleagues are doing these 5 talks. I'm actually doing if you want more details about this, come hear us at 11:10. That's in just a few minutes. We'll be talking a little bit more about vCloud Air and showing a demo, and then there's the talks also shown here. So please do stop by and see the talks. We have a booth also with a nice sofa and a white carpet, so stop by and visit us there. And with that, I'd like to thank everybody. Have a great conference, and thanks again to Percona.